Okay, something is wrong.
Let's take a moment to review some course tips. The following topics are covered in this module.
Okay, ISA IEC 62443 models, ISA 99 model relationships, reference model levels, asset model, reference architecture, zone and conduit model, security levels. These are the topics.
After completing this module, you should be able to identify the models in the ISA IEC 62443 series, interpret how these models can be used in an IACS environment, define the security levels, explain the IACS cybersecurity lifecycle and the activities in each phase, list which courses ISA offers to understand each phase better, and discuss the IACS Automation Solution Security Lifecycle from ISA GCA.
Section 5, models and security levels. This is what we are going to discuss. This is what is being displayed now.
The standard series reference for this section is ISA IEC 62443-1-1. The goal here is to identify the security needs and important characteristics of our environment. We want to get the level of detail necessary to address the security issues and get everybody on the same page with a common understanding of the framework and vocabulary. In other words, share a common taxonomy. All these different types of reference models are addressed in 62443 Part 1-1, Clause 6, page 69. Take a moment to open the standard and look at Clause 6, Models. Reference models provide the overall conceptual basis. An asset model describes the relationship between assets within an industrial automation control system. The network reference architecture describes the configuration of assets, and we'll show you these as we go along. Zone model groups reference architecture elements according to defined characteristics. The models provide context for the definition of policies, procedures, and guidelines applied to the assets. We'll build upon this common model reference structure.
So it is displaying asset model, a reference architecture model, and zone model groups.
The ISA 99 committee used model relationships to develop the standards. They started off with policies, procedures, and guidelines, and then incorporated assets, reference architecture, and zones and conduits models. As you can see in this diagram, they are all related to one another. These models make up your security program, and we're going to take a little bit of a deeper dive into that. In Part 1-1, Clause 6.6, you'll find this figure, Figure 23, on page 89. Pause here for a moment and pull out the standard. Take a look at this Clause 6 on models. We all learn differently. It can help to reinforce your learning by reviewing the slide references within the standards. In any case, it may help you get familiar with the structure and contents of the standards. A reference model describes a generic view of an integrated manufacturing or production system expressed as a series of logical levels. Reference models start off using the ISA 95 approach. ISA 95 is a functional hierarchy. At the top, we have Level 4, Business Planning and Logistics, the enterprise systems. It's all the functions that are related and the activities needed to manage the organization. Financial systems, production scheduling, operational management, maintenance management. This could be for an individual plant or the whole enterprise. We also have engineering systems that are at this level. Moving down to the next level, 3, we include the functions involved in managing the workflows. Here we produce the desired end products such as dispatching production, detailed production scheduling, reliability assurance, and site-wide control optimization. Level 2 includes the functions involved in monitoring and controlling the physical processes. You typically have multiple production areas in the plant. Moving on to Level 1, some overlap here includes the functions involved in sensing and manipulating the physical processes and maintaining process history. The actual production process is Level 0. It's where all the sensors and actuators and DPs, differential pressure transducers, and all equipment is located. Positioning of the functions, such as supervisory control within a reference model, is far from an exact science. The ISA 95 model describes activities and functionality, not the system or network level it's implemented with or on. Sometimes there's confusion about what we call levels and layers. Here, we want to emphasize that we're referring to a functional hierarchy based on levels. This is how you would set up an IACS business model. The ISA 99 committee took the ISA 95 Purdue model and broke it into these sections, which looks almost identical. Note that at level 1 we have safety and protection, which wasn't specifically called out earlier. With our basic control, we start at the top with level 4, Enterprise Systems and Operations Management. Looks very similar, whereas supervisory control is not an exact science. This is just used to create this model. A model is just that. It can change, it can be adjusted or adapted. At level 1 is safety protection and basic controls. Level 0 contains the process equipment under control. The objective is identified as security needs and the important characteristics of the environment at a level of detail necessary to address security issues. We want to have that common understanding of the framework and vocabulary. Now we have a common taxonomy to start with and can engage the vendors that are looking at the big picture. Asset models start at a high level and include everything from the ISA 95 model, all of level 4, 3, 2, 1, and 0 equipment and information systems. They explicitly include networking and auxiliary equipment. It's a generic model that will fit the many situations where control systems are deployed. In this asset model SCADA system example, from a security perspective, the concerns are with the control equipment itself, the users of the equipment, the connections between the control system and components, and all the interconnections with business systems and other networks. There are ancillary connections on the right-hand side that may not be directly part of the control system or the process, or do not interact with it directly, but they are site information systems that provide data. Here we start at the very bottom with the sensors and actuators. Next is Field I/O. Field I/O must contain sensors and actuators, which may be linked by I/O networks. Go up another level, control equipment may be linked by control networks. So the standards are intended to apply to a broad range. This is not a prescriptive model. It'll vary, but we want to come across multiple industry segments and start at a high level and be generic enough to fit the many different situations that are out there. Reference architecture is specific to each situation and review, and it will be specific for each analysis. There isn't any one-size-fits-all. This is simply an example. An organization could have a single reference architecture for the corporation that's been generalized to try to cover all of the operating facilities, but they also may have more detailed reference network architectures and diagrams that expand on an enterprise model. Here is where you start getting into the terminology of zone and conduit models that can be developed from this reference architecture. We'll show you the logical groupings we decided to use within that enterprise as a subset of this whole enterprise drawing. There's no one right way to do groupings. It varies with the systems. That's when you need your subject matter experts to help define the groupings. There's a distinct advantage to aligning the security zones or physical areas in a facility. We can align a control center within a control security zone. By grouping, we can determine the access control lists in the switches and routers and the different devices out there. Zone is our logical or physical grouping of assets. And anytime we talk about that in the 62443s, we're focusing on security zones. Manufacturing functions are being shown, but we want to focus on a security zone protecting that manufacturing function. Here we have Plant A, Plant B, Plant C. The control systems cascade down to the I/O level out in the field. Let's dig down a little deeper on the concept of security zones. What is a security zone? It's a logical grouping of physical, informational, and application assets sharing common security requirements. There can be zones within zones or subzones. Subzones create layered security, providing defense in depth. Zones and subzones must have a logical border, with a device there that controls traffic in and out. The security policy of a zone is typically enforced by a combination of mechanisms both at the zone edge and within the zone. These mechanisms typically include firewalls, routers, and switches. Let's look at a graphic representation. These security zone models were developed from the reference architecture we showed earlier. We described the logical grouping of assets within an enterprise or a subset of the enterprise. We can group by business facility site, or the industrial automation control system itself can be considered as a group. Then we can analyze each one of these groups and zones for security policies, hence the requirements for each one. Here we have the enterprise zone at the very top, shaded in yellow. It includes servers, workstations, the mainframe, and a laptop computer. Now follow it down to Plant A zone, on the left-hand side in the green. Here we find workstations, data servers, and routers. Next is the Plant A control zone, shown in blue. Plant A control zone is protected by a firewall, so it's not connected directly to the enterprise zone. The control zone includes application servers, data servers, and maintenance servers to control the I/O out in the field. This breakdown helps determine the type of security you want to put into each zone. You may decide to break down these zones even further into subzones. By grouping the devices, you can define all the members of each zone. These diagrams can be viewed in Note Set 2, ISA 62443-1-1, Clause 6.5, page 78. Conduits are a logical grouping of communication assets that protect the security of the channels it contains. It's similar to a physical conduit, protecting cables from physical damage. We have a lot of cables and wireless, a lot of channels in a control system. Stated another way, this is a logical grouping of those communication channels connecting two or more zones. They share common security requirements. Trusted conduits that cross zone boundaries must use an end-to-end secure process. The physical devices and applications that use the channels contained in the conduit define the conduit endpoints. Physically, a conduit can be a cable or wireless channel that connects zones for communication purposes. A conduit is a type of zone that cannot have subzones. It's allowed to traverse a zone as long as the security of the channels contained within the conduit is not impacted by the zone. They can be trusted or untrusted. Conduits are defined by the list of all zones that share the given communication channels. It can be a single service, like a single Ethernet network, or it can be made up of a multiple data carrier. A conduit is the wiring, patch panels, black boxes, hubs, media converters, routers, switches, and network management devices that make up the communications path under study. Here we're looking at the zones and conduits with the conduits highlighted in red. I encourage you to take a look at Part 1-1, page 86, Clause 6.5.4. You'll find these diagrams there with more discussion about the zoning conduit model approach. We identified zones so we can break things down and give specific security controls and security target levels. Conduits are the connections between the zones, and they can run into the zones. It's not set in stone how you do this, but you're trying to break it down and determine how to protect your conduit, your switches, your routers, the pipes that connect these zones. This is the wiring, the patch panels, the black boxes, hubs, media converters, routers, switches, network management devices that make up the communication under study. It's amazing what you may find when you do an assessment. If you start crawling into ceilings and finding splices, maybe from a security perspective that's not an issue, but from an operational or functional perspective, that could be a problem, having intermittent loose connections or providing a point where an adversary can easily tap into the network. We've identified our zones and conduits. What are the characteristics we should document? The name or unique identifier and the accountable organization. Who's responsible for the security of that zone or conduit? We need a definition of a logical boundary. That's important so we know where everything's connected. We also need a definition of a physical boundary. What do we need to lock down from a physical perspective to maintain our security level target? Everything should be properly documented. It's important to identify the safety-related designations, or if it contains safety-related assets. It's a little different from the IT, information technology side. Document the SLT, the target security level determined by your risk assessment. Include applicable security requirements and policies. Make note of any assumptions and external dependencies. Be sure to include a list of all logical and physical access points, a list of data flows, as well as a list of all assets. When you make these lists, you can see the equipment that's online. Keep in mind that you may not see the equipment that's offline, so it may require some physical walkthroughs and checking the systems out. Here we have a SCADA zone and conduit example. There's a WAN in between, a wide area network. The conduits are highlighted in red. There are public-private telephone networks and radio microwaves. The zones include a primary control center and a backup control center with similar equipment on both sides. And then there are control zones for sites A, C, X, and Z. Right now, we're looking at our zones and conduits. We started asking ourselves questions like, does that make sense? Is it cost-effective from a security perspective? What am I protecting? Is there a way for an attacker to get in? You can find this figure in Part 1-1. It's figure 22 on page 87. What is a security level? It's a measure of confidence that the industrial automation control system is free from vulnerabilities and functions in the intended manner. In the 62443s, security levels are defined in 5 different levels. Starting with security level 0, where there are no specific requirements or security protection necessary. Level 1, we want to protect against casual or coincidental violation. Security level 2 is protection against intentional violation using simple means with low resources, generic skills, and low motivation. Then, security level 3 is protection against intentional violation using sophisticated means with moderate resources, IACS-specific skills, and moderate motivation. Security level 4 is protection against intentional violation using sophisticated means with extended resources. An attacker has IACS-specific skills and is highly motivated.